Welcome back to the BuildX Podcast, where we explore everything about building better homes, smarter spaces, and the future of residential construction. I'm your host, Buzz Artiano. Today we have Andrew Popielarski and Kaylen Handly with us. Andrew is a senior home energy rater at Home Energy Raters with 12 years experience in the home energy, and Kaylen is a technical innovation manager at Benjamin Obdyke with 21 years of experience. Andrew and Kaylen, welcome to the show.
Thanks for having me, Buzz.
Thanks for having me.
Yeah, absolutely. Kaylen is remote, so we're going to cut back and forth. So I appreciate you taking the time out of your day to come remote. And obviously, Andrew, appreciate you coming back in studio. So we were just talking off camera about what we were going to speak about. I think we should do a few use cases. But before we get into that, I've been in the building industry a long time. I have never heard of Benjamin Obdyke. So if you could take a few minutes, Kaylen, and just kind of get people up to speed, the service area you cover, the company, the history, and what kind of products you produce.
Yes, Benjamin Obdyke has been around for over 150 years. So we were actually founded in the Philadelphia area, and our founder, Mr. Benjamin Obdyke, he actually invented the corrugated downspout back in the early 1900s. So we've been in moisture management for a very long time, and a lot of it was in rolled or broke aluminum or metal for gutters or soffit material. And that business was actually sold off in the late 90s so that we could focus more on the innovative moisture management side. And that comes down to our rain screen type products like our slicker or cedar breather, where we're adding an airspace, or into our drainable house wraps or weatherization materials like HydroGap, which is creating a drainage path behind your cladding. And really, as we've evolved, it's looking at the needs of our industry. And as we build tighter building envelopes and we look at different assemblies and the materials that we're using, we want to make sure that we can build to a higher standard or build better. And that's really where we provide just an array of solutions based on what we're trying to achieve from a performance level and making sure that the assembly is going to work in terms of the layers when we look at the building science focus for different climates and different materials that we're going to use. I've been with the company now for 10 years. And prior to coming on with Benjamin Obdyke, I was in the residential remodel space where we did a lot of historical construction outside of Philadelphia. So it was really a great opportunity to open things up that have been around for 100 plus years and see what worked generations ago. But then it's crazy to see what we've built 10 years ago and is not working. So it's really a progression and evolution of the materials and the assemblies that we really have to look at the education behind what we're doing so that we can analyze and ensure that we're going to install the right products in the right sequence.
Yeah, and so thank you for that. That's excellent. So that was going to be my point. So I know for myself, when I first started, it was, plywood and tar paper, right? That's what we did. I'm talking about wall assemblies for now, and roofs actually for that matter. Grace Ice and Water Shield was kind of the first time I was ever, introduced to anything other than 30-pound felt, 15-pound felt. We had 15 and 30-pound, right? 30 on the roof, 15 on the sidewall. So, and then Tyvek came along, and then Tyvek tape, and all those different things. And I think there's a lot of misinformation, and it's funny what you pay attention to. So lately, as I've been driving around, I've been seeing a lot of blue skin, right? And now that I've spoken to you and done a little bit of research, I see a lot of different construction flaws just in the way this blue skin's been installed on new construction. There happens to be a job, I'm not going to say where right now, but it's the way they've installed it is almost backwards from what they're supposed to be doing. And I walked up to make sure I wasn't seeing it wrong, and I was seeing it right. So again, I'm glad it's not my job. Right. So so that I think that's for contractors and homeowners out there. I think there's a lot of misinformation. I don't think there's hopefully we're going to get to that true source truth source today, so we can say, okay, go to the Benjamin Obdyke website and look at I did watch some of your videos today, by the way. They're excellent on installation of your materials. And say, okay, do it this way, and this is the way the factory is telling you to do it. But beyond that, Kaylen, when they get to something unusual, how does that work? Do you have like an email, a hotline? Like what can the actual contractor do if he's, unsure about what to do? What services do you provide if I'm buying your product?
And I think that is a critical question, is that a lot of contractors feel like they're on an island, that they're just kind of having to figure it out on their own. And that's something that we take very seriously, and making sure that we have someone that answers the phone if you call directly into our line, or if you email into our tech support or into our email, we're going to have one of our team members get right back to you. And also in different parts of the country, especially in the New England market, we have a great sales team that are in the streets, that are in the field, that are there to respond to you and to even help you on site. So one of the critical details, because it has gotten so complicated with the energy codes and airtightness and all these different flashing details, that we want to make sure we can have these conversations up front. So we want to try to get on job site, and we want to try to make sure that we can help even showing a mock-up or a demo of the different products and sequencing to make sure we're on the same page.
Yeah, so that's a good point. So off camera, Andrew and I were talking about that. So I think we're going to do this. I mean, I'm excited for it. We're going to build a little 8x8 room, and we're going to do different products and run real-time blower door test on it. And I don't know, maybe be kind of like a Mythbusters episode, with the smoke machine and, yes. Some mad scientist stuff. So, it'll be interesting. And so we have a bunch of, windows, and I'll get some more, I'll get them from wherever, and we can try different windows and see who's performing and who isn't. And is it really working, and spray some water and spray some smoke. And, I guess we don't want to get too carried away, but maybe it'll be a 5-part series, I guess. I'll keep going until you wear out, I guess. So, typical madman fashion. But so with that, I think, Andrew, I know you have a few test cases, real life scenarios you want to talk about, and we want Kaylen's input on that. But I just want to direct people before we do that. So Andrew was kind enough to bring me a little sample pack of, I'm sure there's more products than this, but this is kind of the everyday stuff. So we have Hydra Flash GP, and Kaylen, if you wouldn't mind just telling the people what Hydra Flash GP is, and we'll show this on the screen later. What's this for? It says general purpose self-adhered flashing.
Yes, this is our self-adhered flashing that we use to integrate all of our window, door fenestrations with our WRB systems. So this can be used with any of our house wraps or our WRBs, so that we can get that great water control or air control or whatever we're trying to achieve. And all of our adhesives that we work with, from our flashing tapes to our self-adhered membranes, they are all acrylic adhesives.
Yeah, what does that mean? I read that. Let's talk about what is acrylic versus what are the other adhesives that people use? Because I didn't know there was a difference.
So as industries change and as technology advances or becomes more readily accessible, we've seen a huge change in the technology of adhesives. So when I first started in the early 2000s, asphalt adhesives were the main adhesives that we were using. That's something that you'd see in, you mentioned ice and water shield or a self-adhered membrane. And asphalt can be a good adhesive, but it has limitations based on temperature range. If it's very cold, it's not going to stick. If it's very hot, it's going to flow or it's going to slough. And we want to make sure that there's also compatibility issues with that type of adhesive. And then in the early 2000s into the 2010s, we saw butyl adhesives becoming more prevalent, where now we're using a rubber-based technology. And this has a lot of great attributes to it. However, it also, if you think of rubber in terms of your windshield wiper blades, it can wear out over time as it dries out.
It's gonna dry out,
and that's something that we've seen with that technology. And now we've been able to take acrylics, which are basically synthesized adhesives that have been commonly used in the aerospace industry, the medical industry, and now we get to use them in the building industry because of how well they handle heat change, UV exposure, and the workability with the acrylic adhesives creates a stronger bond than any of the others. And with that, it actually gets stronger over time. So it'll continue to cure and it will stabilize for the life of the product.
Okay, so for the layman listening like myself, so acrylic is a premium product over everything else we've been using up to date. And this
Yep, we can get a lot better performance out of less adhesive with the acrylics versus any of the other butyls or asphalt-based adhesives.
Yeah, and this Hydro Flash GP, this is a peel and stick product.
That's correct. Yep. Peel and stick. So it comes in different sizes from 2.3 inch, 4, 6 to 9 inch widths. And with that one in particular is a vapor closed membrane. So water vapor can't go through it, has a very low vapor permeance. So that would be technically a vapor barrier.
Got it.
So we do like to use that on a flat or horizontal surface.
Okay. And then we have Vapor Wise, which is the replacement for poly, I'm assuming, on the inside of insulation, correct?
Yes. So with VaporWise, we're able to create a vapor variable interior membrane. So historically, we've used 6 mil poly as a vapor barrier on the inside of our structures in extremely cold climates and into some of the mixed climate space. But the challenge with that is when you create a vapor barrier anywhere in the wall assembly or roof assembly, you are now limiting drying potential. So if water vapor can't go through, that's a good thing in terms of in your cold winter months when it's hot and high humidity on the inside, can't hit a cold surface in that wall. But when we have mixed climates where now in that summer, we have our wall cavities can become highly saturated or have high humidity, it can't dry through that. And that's where we were seeing a lot of those condensation issues with exterior moisture that was condensing on that interior poly because of now the air conditioning that we're really pumping into our buildings today.
And so this is the replacement. This VaporWise is the replacement for that 6 mil poly.
That's correct. So it'll go from a very low vapor permeance in the winter months, and then it'll open up and become a vapor open above 10 perms for the summer months to allow drying in both directions of your wall or roof assembly.
So there's a lot of technology in these products. Even though
yes, there's a lot of research, and that's typically what I enjoy in our department is to be able to understand the technologies, but also understand the pain points and challenges that our contractors have. And that's really one of the fun parts about my job in terms of coming from the field and now being able to work with these technologies, but bringing in our contractors and our architects as to, hey, what do you think about this? Or do you think this makes sense? And really get their feedback. That is something that has really brought a lot of pride into what we do, because our adhesive products like our HydroGap SA, I think you have there, that took over 8 years to develop. Because that was getting it into our hands of our contractors to say, hey, what do you like about this? Or what could we do different so that we could evolve it so that it makes it easier for them to install.
Right. So that the VaporWise is for the inside. Now we have the HydroGap for the outside. And I know the audience can't see this, but this has little dimples on it so that it's called a drainable house wrap. And you have one that's staple on, and then you have one that's peel and stick. And I'm assuming that the differences are obviously the peel and stick is more money, but what's the reason for the two products?
Sure. And HydroGap came out about in 2012, and that's where we really saw the benefit of having just a little bit of space. So on the mechanically fastened HydroGap, you're creating about a 1 millimeter gap, or a little less than a 1/16 of an inch. So it's not going to change your window profiles or details, but it's going to break up the hydrostatic pressure as water gets behind your cladding to allow it to drain out quickly. And that's something that is really key to a lot of claddings that absorb moisture, whether it be fiber cement or a natural wood product. So we want to make sure that we can get that water to drain out and not stay behind our cladding.
Right.
And we've had a lot of great success with our mechanically fastened, but then as we look at our energy codes for air tightness and some of the air control strategies, and with the ability for our acrylic adhesives to also be vapor open or allow water vapor to move through, we could fully coat our HydroGap and now create our HydroGap SA, which is now adhered directly to your sheathing. And now any of the fasteners that are puncturing the product are going to self-seal. So that's going to increase our air tightness. prevent water from getting through any of those fastener locations.
Interesting. And then we have two roof underlayments. One, it says vapor permeable self-adhered roof underlayment, which is the SA. And then we have Invisi Wrap, which is with enhanced UV resistance. So I'm assuming the UV product is meant to be put on where it's going to be a delay in actually installing the final roofing.
So the Invisirap SA is actually a wall product. So that is designed for a WRB application. And you're correct. So if you have larger projects where you have a delay in your cladding or your window deliveries, this will give you a full UV exposure for a year before you have to put your final cladding on. And that can also be used for open joint cladding. So this is a newer trend that we've seen over the last 10 years where we're actually putting joints between our cladding boards. So if you could kind of envision the composite deck world where you're leaving a space between your deck boards, there are actually a lot of manufacturers that are moving to the sidewall applications. You're creating a rain screen, and with that, you're creating a lot more air and water that gets behind your cladding, which is also a lot of drying potential.
Yeah, so I had never seen that, and I haven't had a chance to understand that. But so this is so if you have an open joint cladding, so open joint cladding this is the product to use because it's going to be able to withstand the sunlight.
That's correct. And then also there's no printing on it, so it's completely black. So it creates a unique shadow line aesthetic in there.
And this is
we see a lot on like accent walls. A lot of architects are kind of moving towards adding some texture to the building.
Got it. And so this is a peel and stick product as well.
That's correct.
Yep. And then Vapor Dry SA is self-adhered roof underlayment. So this obviously is peel and stick as well. It has a little bit of texture to it to keep people from sliding on it. And this is used in place of an ice and water shield. This is the ice and water shield.
That's correct. So this is a vapor open roof underlayment that is self-adhered. So this could replace your ice and water shield for your eave protection in ice damming locations. So your eaves, valleys, also approved for the full roof deck. And this product was designed and developed because of a lot of failures we've seen.
Yeah, before you get to that, Kaylen. So one of the things I've done for years is I've been a full coverage guy where I've covered the entire surface of the roof. So this product is rated to do that, correct?
That's correct.
Okay.
Yes.
Interesting. All right. Well, thank you. I think that was very valuable time spent. So obviously you have other products in this, but these are the ones I have in front of me. So I did look at your website. It's very comprehensive. If anybody wants to go there, we're going to put that link in the screen. Lots of great videos. There's a fun video about the company. Definitely watch it. It's a couple of minutes long. About that founder and how he got started and what they do and the testing and all that. So good stuff. So we're gonna bring in some, war stories, right? We're gonna, stories from the world, if you will. So we're gonna bring Andrew into this discussion. So I know you had a couple scenarios you wanted to talk about, and we'll let you explain it, and then we'll get Kaylen's input and maybe what product could have been used instead of what happened.
Yeah. So what we've been seeing. Largely because the energy code is now driving these new construction homes to be so airtight in order to get to the HERS 45 or 42, that in my opinion, it's creating larger indoor air quality and moisture issues that we're seeing for a variety of reasons. And one of the ones that has been the most apparent to me over this past winter is the use of poly as an internal vapor barrier.
So just for everybody, sheathing, some type of insulation, and then poly, and then some type of wallboard.
Correct.
And so you're referring to that poly, the one that's under the wallboard.
Exactly.
Okay.
And that poly in the building code does meet the vapor barrier requirement, but I now believe that it should not be used as a vapor barrier. And what I saw in very newly built homes, that over this past winter, homes that had spray foamed roof lines, but then had fiberglass insulation in the walls with poly as the vapor barrier, had serious condensation going on in their wall
Okay,
cavities.
and where was the condensation occurring?
It was actually, if you look at the a wall cavity, and we could say, there's 16-inch studs there, is that it was happening in the top third of all the wall cavities.
On the sheathing?
Yes, on the back side of the sheathing.
Okay.
So basically what happens is that since this roof line is spray foam, now this house is very tight.
Right.
Which means that
So that vapor used to be able to go up and out.
Correct.
Okay.
And now it's not, so it's tight like a thermos, but you still have the air from inside the house that's trying to go somewhere.
Right.
And now that air inside the house has a higher relative humidity because the home's so tight. And what happens is then that moist air gets into the wall cavities, generally around where the outlet switch boxes and bottom plates, and it then starts migrating up. Following
So it sneaks in the receptacle,
Yep.
goes to the sheathing,
Well, it gets into the wall cavity, and then
Yeah.
it starts working its way up.
up the back side of the sheathing.
And well, what happened, we found, is that like in this house specifically, all the moisture and mold was in just the top third of the wall cavities.
Right.
In the lower parts, there was nothing. And that my conclusion is that that bottom half of the wall cavity is the time it takes that air to pass through the bat.
Right.
And then after it gets past the bat and then touches the back side of the sheathing, that's a cold enough surface to be a dew point, and then it turns to water. And then at that point, when it's cold enough outside, it then also freezes. And now with poly being the vapor barrier on the inside, in my opinion, it then magnifies the negative effects, because now that moisture and water is trapped in that wall cavity, that then in turn makes the relative humidity in that wall cavity even higher, so therefore it then condenses more. And this kind of just keeps building on itself. And also because of the poly, you never see the moisture problem because it doesn't bleed through, so you see it on the sheetrock. So it generally won't be till you're wondering why a wall is wonky that you then open it up to then determine that the whole wall is rotted.
Right. And you found this consistently on all sides of the house, not just the north side?
Correct. The higher floors were worse than the finished basement areas, but it was relatively uniform. And that's when, to me, I was like, geez, this is a huge problem. And for the most part, I would say a large amount of these homes that have been built under this new code were built just that same way. Spray foam roof lines, fiberglass in the walls with poly as the vapor barrier. Whereas then if we were using one of the vapor Ys instead of poly, that condensation very well still would have occurred on the back side of the sheathing, but now it wouldn't be trapped in the wall cavity. So it would be able to dry to the inside. And with their exterior wraps, the sheathing would be able to dry to the outside as well, which over the long run should make the moisture problem a lot less and not lead to where you have mold and ice and these things trapped inside the wall cavities. So
these were fiberglass bats, right?
Correct.
It wasn't a net and blow.
Correct. It was unfaced fiberglass bats with then poly as the vapor barrier. And
2x6 wall.
Yep, 2x6
And
walls.
what was the heating system here?
Gas equipment. They did have ERVs in the homes also, so they were meeting the ventilation requirements that the code requires.
So this was a house built one code ago.
Yep,
Okay.
just a few years ago.
Yep.
And that's when it was like, wow, if this is already occurring in homes that are only a couple of years old, where else is it happening?
Mm-hmm.
The only reason...
And there was no moisture inducing. There weren't humidifiers on the system or anything.
No humidifiers.
Interesting.
But yeah, that's where understanding, right, what's going on in these super tight homes and what kind of conditions are creating this, it's going to be different in every house. And largely it depends on how people are living in the house. Do they cook dinner every night? Or is it just one retired person, eating out all the time?
Right, but we've got to build a house that can withstand the test of time also, right? Because just because the current occupant is there doesn't mean it's not going to, he's going to get married or get, remarried, and 15 kids are going to move in, right? So we've got to understand that just because it's built for that person today doesn't mean it's not going to change.
Right.
So Kaylen, I'm going to bring you into this conversation. So let's talk about the Vapour Ys instead of the 6 mil poly. So this is installed the same way. It's just stapled over the studs. Are we taping? Are we taping the seams of this, or are we just overlapping it?
So we're overlapping it in order to get your basic vapor control. However, we do recommend taping the seams and the terminations to really take it up a notch. When it comes to the air leakage, and that's something that Andrew mentioned, that carries with it a ton of moisture.
Right.
So that's one of the challenges when you're using a vapor closed membrane like a poly, is that installation has to be perfect because it is designed to stop moisture vapor from getting past it. But if it is imperfect, like around an outlet, there was a lot of different testing that's been done through the years that showed in a normal heating season, through one outlet can carry about 50 pints of water on an air leak.
Wow.
So that is just a ton of moisture and wetting potential if it hits that cold surface, like you mentioned. So by having the resiliency and their redundancy with now having something like VaporWise, which will slow the moisture or retard the moisture that's moving through the product, but if it does get past it, it can dry out, is really the key. If you have that higher moisture level on the inside of that cavity, the product will open up to allow drying to both sides of that wall.
So Andrew, on the outside of that wall, what was that assembly on the outside of the sheathing?
It was a more like traditional house wrap, and I think that you want it to be vapor permeable so that it can dry in both directions.
Right.
Is my belief.
And what was the siding on that house? Do you remember?
The siding was like a Cape Cod cedar shake.
Okay. With not an air gap. It was
Right.
tight to the vapor.
Correct.
Tight to the material.
And I believe it may have been a vapor non-permeable wrap on the outside also, which I think added to it.
So they basically created a thermos. Yeah. So they put poly on the inside, a poly-like material on the outside, and then they used a product, so fiberglass insulation. They didn't tape around any of the outlets. There was no sealing went on. And obviously we know fiberglass lets air flow through it versus a spray foam. So it created a perfect environment for that damage to happen.
Right. Yes, and also what we're seeing is that I'm now somewhat in the belief that air sealing outlets and switch boxes is almost impossible.
Yeah, I agree.
Because the sheetrock gap.
Yeah, the wires
and then the knockouts in the back.
Yeah.
And there's a lot of moving parts. You can then seal it, and then the electrician comes in to put their finishes in and pulls the wires out and breaks the seal.
100%.
So very difficult to have that detail to be perfect.
Yeah, we talked about that when you're doing the spray sealant, right? If the wires aren't already pulled out and then he goes and yanks all the wires, he's going to ruin some of that
sealing.
The air sealant, the aero barrier.
Yep.
Right.
Yeah, exactly. And
so that's it. So just a sidebar on that. So if you are doing aero sealing, you really, it sounds like to me that you need to have the electrician come and kind of prep all his wires. Maybe not put the devices in, obviously they're going to get covered, but prep all his wires and then aero seal. That way there it's a minimum amount of fiddling around with the wires.
Correct. And or just maybe the understanding that when they're putting in their finished plugs, that they don't grab the 5 feet of wires and jerk it out of the box and make the attachment.
Yeah, I like the prep part first better.
Right. So that they can be a little more gentle with that aspect of it.
No guarantees on that.
Right.
No guarantees on that. So in that scenario, what do you think would have happened in that assembly if it was a open cell spray foam versus fiberglass?
I think that the condensation wouldn't have ever occurred because the air wouldn't have been able to get to the backside of the sheathing.
Right.
And that's why in colder climates, they deal with this like where the studs are. So if you say we were in Canada and we were dealing with negative 30 degrees, the backside of the sheathing wouldn't be our concern because that's easily a dew point. It'd be actually where the studs are touching the sheetrock on the inside at that cold a temperature. That stud face is now cold enough for the moisture from inside to condense.
And so that's why they went to those offset double stud walls.
And or the exterior insulation.
Right, but for that thermal disconnect.
Correct.
Right.
And that's where that becomes a huge benefit. If you have that exterior insulation, now the backside of your sheathing is protected. So if you did get humid air to get to that surface, it won't be cold enough to be a dew point.
Yeah. So Andrew and I, Kaylen, I'm just going to bring you into this. I'm going to throw you right in the mix here. So Andrew and I was speaking off camera earlier about, window installation, right, and window flashing. And I watched some of your videos on the channel, and it was very informative. And there was kind of two systems for doing that window pan. One was plastic corners, and the other one was a liquid product. And they're both very interesting to me. But in both of your installations, the bottom window flange remains exposed. With I'm assuming the theory is any moisture that's trapped behind it is going to be able to drip out.
Correct. Yep.
Right? So my question for Andrew, and this is one of the things we're going to play around with, is what does that do with the air leakage of the house? Are we now creating a way for the air to come in?
Yes. and that's really the challenge, because when we talk about the exterior and how do we create a continuous water control layer with our window to our WRB, that detail, when we're leaving that bottom nailing fin open, that's something that we've moved towards over the last 15 years. Because before we used to seal off that bottom, have the barrier method. But what happened with that? We saw that the window was failing and water was getting down, and now it was trapped because that bottom nailing fin was sealed. So majority of window manufacturers have moved to leaving that tape out. Do not put sealant underneath of that bottom nailing fin to let it drain. But to your point, for air control, you must then, after you're done installing your window, everything's flashed, your WRB's in, your drip cap, you have to seal all four sides around the interior of that window in order to continue your air control.
Right. So you need to put a backer rod in, and then put some type of spray foam in that, between the rough framing and the window jamb to create that air seal.
Correct. And that was something we've seen. I've been on several projects, specifically on the coastline, where that interior air seal, that spray foam, was not done continuously. And they actually had driven rain that was sucked up through the bottom of that nailing fin.
Yeah, that's what I was
talking about. And they had wood
right.
shims that were sitting on that sill. So now that wood shim acts like a straw. It just absorbed that water, and that shim wasn't concealed in that spray foam. So then it was touching the interior drywall. So now that was absorbing everything in. So it's really looking at things in this holistic manner, where that has to be perfect for that detail to work right.
So that's a good point, right? So thank you. For years I forgot about the wood shim, because I've been pulling those out for years. For that reason, I forgot why I was pulling them out, but I've been pulling them out after the window's in.
Yeah, and we've seen a number of homes where the shims are is actually where the rain is getting driven through on a particular storm around that assembly, because, like you said, they foamed everywhere else, but they didn't where the shim is.
Yeah, they couldn't.
And there'd be a little bit of an air gap. Looks like nothing. You wouldn't ever think it was something that water could come through. But in a few cases, it was actually spouting through like a fountain.
Sure.
And you're like, how is this even possible?
in a high windstorm, right, with a lot of wind, you're going to have a negative pressure on the backside of the roof with the vortex effect, right? So you're actually inside the house can become a negative air pressure, right? And so now it's drawing the water in. Right. It's not so much wind driven; it's actually air driven. Right, it's being drawn into that weakness and pulled into the house.
Yep, and that's why I say that when they do the rough openings, it's important that they either have foam or use caulk to go over the spots where the shim is.
Sure.
Yep. So you air seal those little locations as
so
well.
So the trick there is, if you do have to shim the window for whatever reason, you need to cut those shims back beyond the face of the rough frame inside, right? So give yourself a half, a three-quarter, whatever you can get. Yep. So that you can have a continuous air barrier.
Yep. Seal around that window, especially on something that's on waterfront, ocean, driving winds.
That's how this whole conversation started. Obviously, I have that project coming up in Marshfield, and I grew up on the ocean, so I've seen, rain going uphill and all those things, and, lived through the storm of 78 where 40 feet of the bank and disappeared in one night. So, I can personally attest to the power of the ocean and the wind-driven rain and sea surf and salt and all those things, right? So, so that's interesting. So, and that getting back to your bad wall assembly, we're going to
Mhm.
call it that, right? We'll give it that name. So if they had maybe used a drainable house wrap or a self-adhered drainable house wrap in that situation with these micro, what do you call these beads that are on the back of this product?
We call them spacers. We've
Okay.
had people call them Tic Tacs. Or
Yeah, they do. They do look like a Tic Tac. Kind of small though. I'd be kind of upset if someone gave me a Tic Tac that small. I want a full size Tic Tac.
Tell my guys not to pick them up. Not very flavored.
So for people, there's obviously these little blue pieces of rubber, I guess these are, and that allows so in this case, if on that assembly with the white cedar shingles nailed to here, there would have been a drainage gap built in for that moisture to escape. Plus, this product allows the moisture to go through the backside of it out, and not the water to go in the face in.
Right. And like, let's say you had condensation on that wall assembly, so now your sheathing's wet. The sheathing now can dry through that product to the outside, and then dry through the vapor-wise on the inside, dry in both directions, which is the key.
So that was an imperfect storm, or perfect storm, depending on your view, of that wall assembly. If they had maybe something that breathed on the outside and maybe not to put the poly in the inside, either of those two eliminated might have not had that problem.
Or certainly wouldn't have been as bad.
Right. And so what was the end result of that? They had to gut that house?
Yeah, I'm sure I would think that you're going to have to do a full remediation and rebuild.
Wow. So major problem.
Yeah, at least.
And it wasn't one
ideal situation.
Yeah, it wasn't one wall, as you stated. It didn't. I've seen obviously north side of the house sometimes can be worse than the sunny side, obviously, right? So this was consistent all the way around.
Right, and the scariest part is you would never know. There was no visible signs.
How was that discovered?
I believe they were doing some minor changes in one area where they wanted to change some windows or doors or something.
And then that's when
so they opened up a little bit of an area, and the contractor found this. At that point, some time after that was when I got brought on site to try to figure out what was going on, and we opened up other access to different areas, and they all had the same issue.
So that was a bad day.
Yeah, and it's a learning experience, right?
Yeah, for you, but bad day for them.
Sure.
Yeah.
But the scariest part to me was the fact that how many thousands of homes are sitting there with this going on right now, and because they didn't open up any wall cavities, you don't know, right? So that's where you're like, geez, if half the homes getting newly built over the last 5 years were all insulated this way.
Yeah.
And the sad part is that it was, to code by definition, and there was a lot of details that were done that were details you'd like to see, as far as like picture framing every bay to air seal it with foam before the bat went into the cavity.
Really?
Yeah, caulking, top plates,
so it was well
headers.
done, just poor products.
I think so, and that's why I tell everybody now that use any product other than poly as for a vapor barrier.
Right.
And then
have something on the outside that's going to breathe.
Right. And I also think
this was plywood or OSB?
Plywood. Yep.
Wow.
And I also think too that then controlling your inside air humidity and conditions with your ERVs or HRVs becomes extra important also. And then the factor of not knowing how people are going to live in the house. Is it a family that's living traditionally, or is it a person who owns a pet store and has 10 aquariums in their house? Right. Very different relative humidity conditions, and the ventilation needed to be very different based on those
or if it's somebody that's very susceptible to dry air and they're running 5 dehumidifiers, or they hook up a central humidifier, right? And they hook up a humidifier to their system and turn it up to 50%.
Right, exactly. Right? And then the big issue in our climate zone is in the winter with the higher humidities. Yeah. And the thing about higher humidity with these tight homes is it makes it feel very comfortable.
Yeah.
So you're like, cozy. I love this new home.
Yeah, it's cozy.
It's so comfortable. It's so warm. I don't feel any drafts. But now they're not realizing that they have condensation occurring in their walls that they're maybe never going to know about.
Yeah, the silent killer.
Right. It can be, and that's nonetheless you have people that have allergies.
Yeah, well, that's the other thing. So you have people that are mold susceptible, obviously, right? Or autoimmune disease and other things, and they're gonna obviously that heightened indoor lack of indoor air quality is going to really set them off.
Right.
And they're not, then they're going to be chasing that, trying to figure out why they don't feel good when they're at home.
Right. In their new house.
Right.
Now they have sick building syndrome, they call it.
Yep.
And now there's a lot of symptoms for people not feeling well, lessened productivity.
Yeah. 100%. Yeah. So it's interesting. So I have 2 customers right now that both have, known issues with, VOCs and other things. And so we're spending some time now, researching. So actually, that's a good question. So these products, are these, people sensitive friendly, I guess, for lack of a better word? What is the terminology I'm looking for to say this is okay with someone that is sensitive to vapors or vapor emissions?
So, and that would be another benefit of the acrylic adhesives. We don't have the potency or the pungent smell that comes along with some of the different asphalts type of adhesives. So the VOCs are extremely low, so safe for those type of assemblies. And because that's another unintended consequences of going to a very airtight, energy efficient home is now any off-gassing that were occurring from any of the spray foam or any of the other products that we're using, it's now a lot more prevalent because we don't have the air leakage to kind of refresh the air. And so, our customers will notice it more. And you mentioned about how that customer you were talking about was an expensive day when they found out that they have to remediate this house. But also they're actually very lucky because if that was going to continue for the next 20 years and you're not understanding what was happening or you don't see the damage, it's the mold growth that it's actually going to be more detrimental. And that was something that we have seen within the Mid-Atlantic with stucco. Over the last 20 years, we've been messing up stucco assemblies and it's been catastrophic, but the stucco looked good. The drywall looked good, but it was the mold that was in the inside of the wall that just destroyed everything.
And that was the stucco leaking, the flashing details?
No, that was just the building blocks. The layers were incorrect. And that was the reservoir cladding of stucco absorbing water. It was drying out and turning to vapor, which was pushing through a high perm rated house wrap into the OSB and just stayed wet and could never dry. And that's why we finally had codes change come through in 2021, which are now for the first time showing that a rain screen assembly behind stucco in a wood frame construction is the best assembly for the life of that wall.
And so that's going to allow that moisture that's trapped in the stucco to migrate to the backside and then escape that rain screen.
Correct. Yep. And that's really what we're trying to talk about with all of these assemblies is drying potential. Is the more that we can have drying potential in these energy efficient buildings, the better we're going to be in the long run.
So for me, just as a sidebar, for me, I'm always afraid, right, of the new idea, right? So, for years we did this, and then they said, I'll give you an example. I was building over in a subdivision years ago. This is, early 2000s, and they had just come out with I'm going to call it the pressed cardboard clapboard. I forget what the name of it was, right? And I was installing regular clapboard, which is obviously, I think at the time was twice the money, right? And then we were doing white cedars. And this builder, I'm not going to name his name, decided they were going to use that product because they were saving, a couple $1,000s a house. And I remember going over and looking at it and reading the instructions, and it essentially said that if you don't do all these things perfect and seal the ends and do this and do that, and every place you cut it, you paint it before it goes up, etc., then water's going to get into it. And so I took a piece home and I just put some hot water in a bowl, and I stuck the end of it in and I left it overnight, and I came back, and the next day it was twice as wide, right? And I said to myself, there's no way that you can possibly install a whole house of siding and not expect some water to get in between those joints, right? Just between the window gap alone, just to the, the trim, never mind between the siding. And sure enough, about 5 years later, there was a massive recall lawsuit, and all those houses got stripped off and new siding put back on. Thankfully, not on my dime, right? So, so I'm very paranoid about the latest and greatest. I really want to see version 2, if you will, on most things, right? So my question, and that was a long way of a lead into you, Kaylen, like, tell us about, how do you test these products to make sure they're actually going to not cause a problem like that 5 years from now that we don't know is coming?
Yeah, a lot of the testing that goes into the products are based on industry standards, as far as there's a lot of ASTM tests that are kind of gives you a general baseline in terms of this material is going to perform in this manner. It's going to stop water from going through. It's going to allow water vapor to move through at a certain rate. And a lot of that is in the code in terms of this is the bare minimum that this product needs to perform. And then we take it up to another notch in terms of we want to look at accelerated aging. We want to look at long-term UV exposure, because in my experience, contractors were always going to push the boundaries of what the limitations are for a product.
Sure.
So I want to know, okay, if this product is exposed for 6 months, is it still going to perform, even though it's supposed to only be exposed for 4 months? So we always have to have some sort of an engineering safety net, if you will,
Sure.
in there.
Safety
So
factor.
based on all of our specifications, we try to put it through the ringer into a higher level of testing in order to make sure that it's going to work in the field. And then also, like I said before, is that we're trying to, and as we develop these products, is take these to our contractors so that they can put it through the ringer and they can say, you know what, this is not strong enough, or you know what, this coating here needs to be a little bit more robust, or those spacers need to be thicker, whatever the case may be, so that we can actually get a real world experience. Because in my experience, something that is designed in a laboratory and then put in the market is not going to work in our field.
Right.
So it needs to be kind of really held accountable for what it's going to do. And really, it's also the assembly that we look at, so that we can have redundancies in our assembly for drying potential, and understanding that what window we're installing, so we understand what their installation is, so that we can make sure that everything works together.
Right.
Yeah, Buzz, kind of a good point is that, all these older homes, let's say even 20 years, 50-year-old homes that we look at and you open up for a renovation now and you're like, oh, I don't see any major mold or moisture issues. And a lot of the reasoning for that is because they were so leaky that they could dry.
Right.
And the drying capabilities is what was so key for these old homes that are now 100 years old, 200 years old, and are still there, that didn't have this issue, because although they were getting condensation happening in their barely insulated envelope, it was drying.
Oh, yeah.
And
No, I
that's
mean,
the key.
I've seen real world examples of that. I was on a couple restoration jobs, fire restoration jobs, brick exterior, and the rest, the remediation called for, spray foam on the inside on the backside of the brick. And I remember saying to the person, that's a mistake, because that brick leaks when it rains. Absolutely, there's water that if you stand here during the next rainstorm, you will see water running down the backside of that brick. And this building has been standing here a long time. I think it was like 100-something years old. And sure enough, they did it anyways. And the next winter came, and all the bricks started spalling, right? Because all that trapped moisture had nowhere to go. And as soon as it froze, it started blowing pieces of the brick off.
Wow.
Right? So you've got to, like you said, you got to have your head on a swivel. You got to have people like Kaylen you can call, or yourself, and say, hey, this is what I'm thinking about. This, I watched this YouTube video, I looked at this pamphlet, but my particular assembly, for whatever reason, doesn't make sense to me, right? Let's unpack this, right? I know you were on a phone call earlier, before you came in here, talking to a contractor, talking them through something, right?
Yep.
So it's good to have that trusted voice to say, what about this? What about this? Here's a picture of that, right? So the theme of that is, don't work in a vacuum, as Kaylen said, reach out, get some help. Manufacturers are here to help. You're here to help, right? So it's important that people understand that. And I think sometimes, and I've been a victim of this as well. You don't want to look stupid, right? You feel like, I should know this. But honestly, the older I get, I realize that, it's impossible to keep up with all this.
Sure.
Right? You need your experts, right? You need someone. This is all you do all day, right? So when I call you and I say blah blah blah, I know it's the right answer. I call Kaylen, I'm like, hey, I need to do this with that, blah blah blah. That's all he does, right? And he's going to be like, yeah, we do this, we do that, you use this, use that. This how flashing detail has to go this way. Do the wet, again, these are made up. Do the wet assembly, do the thing with the flap like we talked about, right? so that when you bring that up and that flap can go over. And that video was actually very helpful that I watched on their website. So earlier we were talking about another bad case scenario. Maybe we can unpack that one and talk about what was the failure point of that.
Yeah, so another situation that I've seen now a number of times is the use of OSB for siding and or roofing paired with open cell spray foam for the insulation.
And this was not zip, or was just regular OSB?
Yep, regular OSB.
Okay.
Very well, they may have done ice and water over the whole roof. Then 10 to 12 inches of open cell foam in the cavity. And
right over the rafters, so completely covered.
Right. Well, it was vaulted, so it was sheetrock over it, so it was like full cavity.
So it wasn't over the face of the rafters.
Exactly.
It was up to the rafters.
Right.
But there was still a little gap there.
Right. And in this case, there's also in that part of the roof, once they took down the sheetrock, because there was a bunch of moisture that started coming out, and they thought they had a roof leak. And after looking at
So wait,
Yep.
just unpack that. So there was enough moisture condensating that they thought they had an active roof leak.
Yeah, so they had what they said is an incident that was like in the fall where about a bucket full amount of water just dumped out into that room from the ceiling at one time.
Wow.
And I was like, so they're like, well, it must be some sort of roof leak, this and that. And I'm thinking about it and I'm like, So it was not a roof leak. And what the conclusion we came up with is that area of the house was right adjacent to a bathroom that had a pocket door and had a shower in it. They had no ERV or HRV in the house. And also, when they took down the sheetrock in that area, there was sistered rafters next to each other that I'm sure was structural.
Wait, just for everybody at home, so the original rafter was here, and they put another one next to it to strengthen it.
Right.
But that created a little gap.
Correct. So the cavities in the 14 and a half inches next to that were all full of spray foam.
Right.
But enough air was able to sneak between the sistered rafters, in my opinion, to get to the backside of the OSB and then turn to water. And then that water just absorbed into the open cell foam and into the OSB. And what I think is that kept building up all winter long. And I think likely, a lot of it was frozen up there on the backside.
Yep.
So then this event was that melting.
Yeah, so they had a purge.
Right. And I think too that open cell foam just being wet for a long period of time, it may have had a point where it just kind of pushed off.
Burped it.
And then whoop, and the water just all dumped out.
Wow.
But then when they took all this open cell foam out of the cavity that was all soaked, and we got to the OSB was deteriorated to the point that I could have just put my finger right through the roof.
And how long would that assembly been in place?
I mean, this house was a couple years old at least.
Okay.
So it could have been.
So it was relatively short period of time, 2 to 4 years.
Right.
That occurred.
Right.
And they had no indication other thing was going on until they had that event with the water.
Exactly.
Down. Right.
And that's why they're like, it must be a roof leak. Like,
sure.
And at first I'm thinking, if it's just a big dump of water comes in, it seems like it should be. But then the more you kind of get into it and look at the situation that was going on, it was like, well, now every time someone's showering all winter long, God forbid someone's not turning the bath fan on.
Yeah.
A lot of that moisture is getting up
just
into
even
that area.
A cathedral ceiling, heat rises, right? Yep. So all the moisture, everything's going up, not just the bathroom, but everything's going up there, right? And then there's nowhere for that to go.
Right.
So it's not like there's a hole in the roof letting that hot air out. So now it's going out. Right. It's finding the space between the sheeting. And so that's a good point. And I remind myself all this time. So when I go to look at something that doesn't make sense, you have to be careful not to predispose yourself to what it is, right? So you have to keep an open mind. Yeah. Because like you said, they were convinced it was a roof leak, right? And then upon further investigation, it was about to be a roof leak because there was no sheathing left, but it didn't start that way, right?
And I would say the majority of these over the years, we've probably been brought in anywhere 20 to 50 different homes that have had what they thought at the time, they told us over the phone, was a roof leak that they all thought, but every single one turned out to be moisture condensation and not a roof leak. And a lot of them were vented attics, that they went up in their attic in the winter and there's ice on the underside of the sheathing. And they're like, oh, it must be a roof leak. The water's coming in and freezing. But it was really just the humidity from the house leaking into the attic, and touching the backside of the sheathing, turning to water, and then freezing. And then that just kind of reoccurs all winter long.
I've gone up in there and seen an inch ice on the backside of on the sheathing, especially if you find the ones that, somebody did a bathroom renovation and didn't vent the bathroom fan anywhere. So they're up there. They're cranking away with the bathroom fan thinking they do the right thing, but all they're doing is introducing all that moisture into the attic. It has nowhere to go. So, and then the other famous one is we have a roof vent, but when you actually look up there, they took the ice and water shield or whatever and actually draped it over the top of the roof vent. So it's it looks like a roof vent, but it's not a roof vent anymore, right? A ridge vent. So pretty interesting stuff. Well, that was good. I learned a lot. Any parting thoughts, Kaylen? Words of wisdom, things you want to tell the audience?
Well, I really appreciate the time here. And I think the biggest takeaway is that things have gotten so much more complicated. And really, we are here to be a resource for you. So if you do have questions, please reach out and we can refer you to our sales team in different parts of the country. And we're always open to talking through the details because, a lot of these failures that we talk about, it's a lot more common than it was before. So it's really critical to get these details right the first time so that we don't have those issues where Andrew has to come in and take things apart to see what's really going on.
So that's a good point. So just that brought me to an idea, and I don't know if you already do this. So I know you have local reps in some parts of the country, correct? And do you ever put on like clinics for people to attend and say, this is how you use our product?
Yeah, we do a lot with our distribution partners as well as our dealers. To have contractor events, or we do a lot with the architects in order to talk through and show demonstrations of how to install certain products for different assemblies.
And so how would the average contractor find those events? Is it are they publicized on your website, or we have to reach out to our material supplier? How would we know, to attend that?
So a lot of them are, we broadcast through Instagram, or we'll send email blast out, or if you want to connect, just feel free to give us a call or send us a request link through our website. There's a lot of different ways that you can, shoot us a note, and that way we can kind of put you on the email chain, but you can also learn through your different lumber dealers or distributors in the area.
Okay. Andrew, final thoughts?
No, I just think that the more we understand what's going on with these homes to try to prevent, having moisture problems, it's probably one of the scariest things now in the industry for builders. Because when you just look at having to deal with something like that.
I think it's every real contractor's nightmare that you think you're doing the right thing and you're actually creating a hand grenade, a massive deferred liability. That's the stuff to keep you up at night, right? So, that's good stuff. Obviously, second episode, you're a two-timer now. I think we do good together. I think it's good stuff. So. We're gonna do that. We're gonna do that little demonstration room. I really like that idea. We're gonna get some free product from Kaylen, and we're gonna get a free window from somebody else. And
aren't you also doing the Hydro Gap on one of your upcoming projects?
Yeah, we are.
Too?
We're gonna do some filming of that as well. And I haven't honestly, after having this discussion, I need to reach out to Kaylen again and have a more in-depth discussion now that I've got my head straight. I think so because I am. I'm very concerned. I mean, I've worked on direct oceanfront, but this is a severe environment, this particular installation, because there is a seawall that's going to cause the air to come up like this and then in. So it's almost doubling the effect, if that makes sense, because you've got, say, 20 feet high of air, and now 10 feet of it gets blocked by this vertical seawall. And so that has to go up and go. So it's almost doubling if you think about it, it's acting as a funnel, right? To really concentrate that air and that flow of whatever's coming at the house. So this is an interesting one. It's not like it's oceanfront where the wind's coming steadily. It's creating a concentrated wind force.
Right.
Right. So we got to be careful of that one. All right. Well, that's a wrap for today's episode of the BuildX Podcast. Thank you to Andrew and Kaylen for your help today. Anybody we'll put all the website information. Please subscribe and like and share if you enjoyed it. We'll see you next week. And remember, just build, baby.